Morning. Now we are on the last module of Unit 4. This module is talking about refining relationships. So what you will see, we are going to look at the following things. We're going to look at defining dependencies, association, generalization, and then lastly looking at resolving use case collisions. Now what we are seeing quickly, if we mention what is a dependency, we see it is a relationship between two objects, but it's more of a non-structural relationship. So it's a places where we can't really have an actual relationship, but it's in cases where we are where one class, for example in this case the client, is depending on the supplier. So what that means is that the structure which the client provides us, in that case, in which the supplier provides us. So this is a class with specific attributes and operations. But if I create an object in my client, that means it is going to depend on that one. If you are in your IDE and you go and change some section in the supplier, in that guy, it means that it possibly is going to complain in the client that you actually have not implemented this properly. There's now a new method or new attribute which you need to consider. So that is where dependency is getting in. Now what you will see is that there is three types of dependencies, which is a local variable reference, parameter reference, or a global reference. For us to create an association, it's normally just done by a field reference where we're creating a relationship based on the field which points to another class. Okay. So then there's a bit of more about when do we use it. What you will see, a dependency is also a transient link. What does transient mean? It's only temporary and you can't really see it. You need to actually analyze at code level this to see, is there a dependency? Okay. Now, then they quickly talk about, for example, local variable references. So if we actually have a class diagram like this, and inside class A we have an operation op1, and inside that operation we're creating an object of a specific class, in this case of class B. What does that mean? It means that we are requiring an object which is based on this structure in there. In that case, it is a dependency. Because the moment I change the structure, class B, it is also going to change the object which I have inside that operation. Okay. Then we also have parameter visibility. Parameter visibility talks about two things, either being the parameter of the input in terms of the inputs. As in this case, we have a parameter which is based on class B. So we are sending in an object which is based on a specific data type. But it can also return something. So a parameter or an operation can also return to us a specific data type. In that case, it doesn't need to be just like string or double or integer. It can also be an object based on a specific class. Okay. That is also called or part of dependency. Then we have global visibility. What we're seeing in this case is that they have an operation which is globally visible to it, and then you're creating objects to it, and that thereby creating a global dependency. So what they're quickly doing is, how do we identify what is the considerations that we need to make for normal permanent relationships like our associations? They will be based on field-based association, which is added in. Then what we're seeing with dependency is normally creating for us a transient relationship where multiple objects really share that same class or same structure. Now, what we're seeing is we're then passing instances as a parameter or parameter visibility in that case, or making an instance as a managed global object, thereby using global visibility. Or if multiple objects don't share the same instance, it can be considered local visibility. Okay. So what we're seeing is that also how long does it take to create or destroy? In some cases, it can be considered expensive if we used field or parameter or global visibility, because it needs to possibly connect to many other suppliers, in that case, or other classes. So we need to strive for the lightest relationships, lightest connections. Okay. So then they quickly have a diagram for us where we're seeing and we're defining dependency. Now, in this case, we can see, for example, here we have a student, and it takes in a parameter a schedule of schedule. So in that case, that is also parameter-based dependency. And the next one, where we have for semester schedule, also again, here we are seeing that we're taking the semester one in, which is not mentioned on the actual class diagram. But in that case, a semester would probably also become a class. Then we have schedule, which is again parameter-based. Okay, so they've quickly annotated it to us to show to us where we can see global or field-based visibility. Okay, so what you need to take from this is that we can look in terms of these class diagrams and actual code to rather go and look at where has the dependency been implemented, what type of relationships are we having, and then we possibly need to refine this. So in this case, we might need to make it a bit more simpler, that we don't take have a very complex structure where we are depending on a lot of classes. So then we're going to quickly look at defining associations. So you'll see things which we need to consider is, for example, association, aggregations, composition, all of those stuff again. So we have spoken about composition in the past. Now what we're seeing is it's similar to aggregation, but in this case we have a filled-in diamond where it's denoting to us that there's a strong ownership between the whole and the part. I can't, if I remove the whole, it's also going to remove its parts, and so on. So then there's a mention quickly just about shared and non-shared aggregation. Where shared aggregation, what we're seeing is the multiplicity on the whole side is now actually telling us that it's a one-to-many cardinality. Or non-shared, what we're just seeing is just one there. Even for composition, in this case, it's also just denoted as one, and it tells us that this part can only belong to one. Okay, so it's almost like saying these desks can only belong to one venue. Okay, but the chairs in this venue can possibly be used in, if the chair is considered part of as a part, it can be used in many different venues. Okay. Then there's quickly a consideration which they mentioned to us, that we need to consider which the lifetime of, in this case, do aggregation or composition. If we're implementing something like composition, you might need to, inside your constructor, you need to go and say to it, if I create the whole, it needs to create parts. And then you also need to go and look at possibly adding a destructor. If you remove this guy, remove those guys. So it's having a very big effect on the rest of your system. With aggregation, it doesn't have that big of an effect. Then there's quickly just a mention for us also about student and schedule. What we're seeing is that we have a student and the schedule relationship. Now they're telling to us that it's composition. Why would it be composition?
Because if we remove students, also schedules.
Okay, if we remove the student, all of his schedule entries is going to be removed. If you remove the schedule entries which depend on that student, you're going to possibly later on actually remove the fact that he's going to be a registered student or a student. Okay. Then there's quickly just a mention about when would we use attributes versus composition. Okay, so we would use composition when there's properties, our properties needs independent identities or multiple classes and really need that same structure. Okay, so what we're talking about is almost is like this. If multiple classes are requiring the schedule, and the schedule consists of a semester and a bit more information possibly, we won't model it as attributes and just place it inside the student. We would place it as a class separately, then it can be used by all of the multiple other classes which needs it. Okay. Then there's also quickly just a mention about navigation, or now what navigation really tells us again quickly the direction in which we can navigate. So we can navigate from the registration controller to the schedule, but I can't go from the schedule to the controller. So then there's also a bit of a discussion about which direction is really needed. So if we're looking at the schedule to course offering relationship here, okay, so we might need to go and explore our interaction diagrams, your sequence diagrams, your class diagrams also, to see what direction is more prevalent, which one is happening most. Okay. So when both of the directions seems required, one may only, sometimes only one may work. If the navigation is in one direction, it's infrequent, so it's not happening that often, or a number of instances of one class is small. So what we're seeing is, yeah, this guy is saying to us 0 to many, 0 to 4. Which one is going to be the most? So what are we seeing? The schedule is going to be the most one in this case because it's telling us that it's 0 to many. But also, when we're offering a course, there's many students who can actually take the course, so there's many guys who's going to actually have it in his particular timetable. That's what, in essence, what it's saying. So then what do we need to go and look at is quickly this. So which direction are we working with? Then on the next slide, I have a very big discussion about it. Where, for example, if we look at this one, if the total number of schedules is small or never needed, or we don't need a list of the schedules on which the course offering appears, then we would probably have something like this. But in our case, what we're seeing is that the total number of course offerings is rather small compared to the schedule. Okay, so, and also we never need a list of the course offerings on a schedule. And then, do we need something like this? What it's saying to us is, do we need a list of course offerings? Do we need a list of subjects? And then to say, these students belong to these subjects. But what about if a lecture wants a timetable? A lecture wants a class list. In essence, what he is, he's getting the course offering and the student. So where do we see the student information? It will directly be connected to the schedule, because from schedule we connected to the student. So it would probably be modeled something like this in this case, where the total number of course offerings and schedule are not small, but in that case we don't know. In this case, it's just telling us that the schedule can have 0 to 4, so meaning that a student can only take 5 subjects. And then from the course offering, that specific subject can have many students. But how many subjects can there be? We don't see that information here. Okay. So in this case, also it must be able to navigate in both directions. So we would like to get to a place where we would like to see the subject and then the student which appears on the subject. Okay. Then there's also mention quickly about the association class, and now what we're seeing here is it is attached to an actual relationship or association, and it is attached there with a dotted line, and it's modeled just as a plain class which is connected to it with a dotted line. So what do we add in here? In this case, we have the grade. Does the grade belong in the schedule or the course offering? So your final mark, does that final mark need to be inside the student, or inside your schedule, or inside the actual subject? So you are saying to us the grade will be in there. Why? But in essence, we are grading the student for a specific subject. Is it not? So if we are to model the course offering, what attributes will you have in the course offering? What attributes will you have in there? Course offering being the subject. So we will probably have the subject name. Subject code. Are we going to have your mark in there?
No.
So you now start to see that your actual mark, your grade, will not go in there. And it will also not go into your schedule. Because what do you have in your schedule? If you look at your timetable, you have Monday, 10 o'clock, your software engineering. Okay. Yeah, but that you get because there's actually a relationship between schedule and the actual lecture. You remember that one of the previous diagrams depicted it in some sense. But your grade, you will get, and it will be modeled as an association class. When do we get association classes? When there is many-to-many relationship, or in some cases a one-to-one relationship. But when this information we are modeling here doesn't clearly belong to either one of the two classes. Okay. In some cases later on when you do database design, it can possibly be denormalized, and then you can take the grade and place it somewhere else. But it's becoming, you know. Yes? So what we are seeing is that this guy will be another entity. Yes, it will not. It will not. So ultimately, what it means, if we look at the modeling, if we have the course offering and we've scheduled. In essence, what it says to us is that we are going to have a class that sits in the middle, which is going to be this guy. So that will be it will become something like that. But what we are seeing is that even the multiplicity is telling us to have a 0 to many and 0 to 4. But what is now going to happen, initially where it was, you just write it down. 0 to many, 0 to 4. What we are now going to see is this is going to turn around because the way you read this relationship changes a small bit. This will become just 1. But I also switched them around. Let me just correct this. This is actually supposed to be 0 to 4, 0 to many. I've written the schedule on this side, the course offering on that side, where on the presentations are around. What we are seeing is that this one is going to go over there. So if we read the relationship, what are we going to see? We're going to still have, for a specific schedule, you can have 0 to 4 subjects. For a specific subject, there can be 0 to many students doing that subject. If we go to the original relationship for a schedule, there can be 0 to 4 specific course offering or subjects related to it. And then for this subject, there can be 0 to many students, or schedule entries actually. Okay. So just note the relationship changes a bit around when you're modeling it, when you need to have a look at it. Okay, so there's another example where they're breaking down and they're actually just showing to us that how they have actually broken it down. So what they've also done in this case, they've looked at the navigation and the direction to which it's going to be. Okay, so then there's also quickly a matter that they're talking about multiplicity design. So in some cases we might need to go and re-look the multiplicity. When it's just 1 or 0 to 1, it's very simple and it's actually easy. But how do you handle a multiplicity which is more than 1? When we get to this, professor can actually be related to, or the instructor to, 0 to many different courses. What this is talking about is this is not now a place where we can just use a simple attribute inside it to create a relationship. We now are talking about having arrays and array lists, because in essence this instructor can be associated to many different subjects, and that subject can be, the list can grow. So one of the ways which we have in programming to handle this is when we're starting to work with array lists and arrays and so. Okay. So that's why they're saying to us that further design may be required in this to properly do it. What we're then seeing is that they're also looking at ways of implementing this. So then they're adding also possible note in here to say, but I might need to use a list to model that properly. Okay, so they've just added a note onto the diagram. So you can have a look quickly. Also, there's mention of parameterized classes, where a class definition that defines other classes. So some of the containers which we start to see this is when we work with sets and lists and stacks and queues and so on. Then we're getting these, basically a template which we create, and that allows us to instantiate many objects of that specific template. Okay. So there's a mention where we had the course offering earlier on the list and the actual course offering. Now what we're seeing is it possibly can be modeled like something like this, where the course offering list can be modeled as a list with specific items, but as a parameterized one there. So what we're also seeing is the optionality is that when we include something like this, or 0 to many, or so on, we might need to include something to actually go and test is this professor teaching? To actually test, does this relationship exist? To test on that existence of that information for us. So you will see there's also quickly a matter where they're talking about refining generalization, and we've spoken about generalization in the past, where we see a parent and we see some children, and when we start to see that this phrasing is a kind of savings account is a kind of an account. So when we started to see that those words, we start to see that there is a form of generalization. Okay, so what they also mentioned to us that we can have abstract and concrete classes. Now, when abstract classes, it tells us that there is no direct instance of the actual animal, but all instances which needs to be created must be created from the actual children. So this is the place in programming where it's getting a bit hairy, especially when you're starting to look at generalization and inheritance structures. Okay, what we also are seeing is here is that we have an abstract operation, communicate. And then we also have communicate there and communicate there. Does a lion and a tiger communicate in the same way? Both of them roar, but they actually have different pitches and it means different things. Okay, so in this case we might have an abstract operation, but that means that to us the next time we implement this as a class, we need to actually implement that operation. You actually must write the actual code for what is this communicate going to do for the line. So then there's also problems which we can get to multiple inheritance with the name clashes on attributes or operations. What we're seeing here is that we have color, get color, color, again get color, and bird. This is also a place where we're seeing that the bird depends on two things. It's multiple inheritance. This is not always a thing which is handled with all programming languages the same. Okay. Then we can also have a repeated inheritance structure where we have animate object, and you can have animal, a flying thing, and a bird. You can create a hierarchy. Okay. So this, what you just need to note, the solution to these problems is implementation dependent. So basically, the language which you use, your current situation is dependent on all of that. So then they quickly just mentioned to us the possible constraints which we can have on a generalization, which can be, for example, a completeness constraint, incomplete, disjoint, and overlapping. Complete meaning that it is the end of the inheritance tree. You cannot go down further. Incomplete means that the inheritance tree may be extended at some point. Disjoint means that your subclasses are mutually exclusive and doesn't support multiple inheritance in that case. Overlapping, your subclasses are not mutually exclusive. So if we quickly look at the diagram where we start to see this. We have an asset. Then they tell us that it's disjoint. So this asset can only be a bank account, a real estate account, or security. It cannot be a bank account and real estate at the same time. Okay, so if we have an object of an asset or so on, then it can only be a bank account or a real estate account or security. It cannot be multiple of them. Then we're seeing that there's a disjoint and complete, meaning this will be the final end of the inheritance hierarchy. So that is why we're seeing savings and we don't see anything down below. Then there we just see that they mention the multiple inheritance is not supported. where we have this joint and so on. Okay. Then there's quickly also a continuation of this where we're seeing the mention of overlapping, where we have a vehicle which is considered a land vehicle and a water vehicle. So they created an amphibious vehicle. Okay. So what we see in some cases, the generalization and aggregation are often confused and are often not modeled correctly. As what are we seeing with the phrasing? Generalization represented as a, by using the words is a or a kind of wording, where aggregation tells us we're just talking about a part of relationship. So what are we seeing? This window with the scroll bar is a kind of a window, or is it kind of a scroll bar? Or is it this window with a scroll bar is part of the window and part of it is a scroll bar? Which one of the two is it now? So what are we seeing? Sometimes it might be rather modeled as the window with a scroll bar is a kind of a window. But the window with a scroll bar, as part of it, we have the scroll bar. So this one of the two is now mentioned as composition, but we also have inheritance there. Okay. Now then, there's just a bit of a continuation where they just try to talk about the class substitutability and the way of substituting it, and so you can just have a bit of a more of a look about this. Then they go and talk about quickly the principles of, back to the principles of object-oriented programming, and one of them was encapsulation, and then what the other one is polymorphism. Now polymorphism talked about actually the ability to hide many different implementations behind the single interface. Where this is going is to have this. We're talking about communicate, but a line communicates in a certain way and a tiger communicates in a certain way. So if we use polymorphism, we're just going to say, but this animal communicates. But if we are doing it without polymorphism, then we need to say, but the animal we're working with is a lion, then we need to call the lion communicate. If it's a tiger, then we need to call the tiger communicate. So if we are working with polymorphism, it then have ability to understand which one are we working with. So then there's quickly a matter where we're talking also about interfaces and generalization. Did you ever use interfaces in programming? Not a user interface. An interface, what we are seeing is it basically gives us a abstract declaration of the public methods of the structure. Okay. So the interface may support implementation, independent representations of your polymorphism. It can get to a place, I think there was an actual diagram. Yeah. Okay. So interfaces are pure specifications, there is no behavior in it. So what are we seeing is that you can have an operation, but it's only the signature which is going to be declared there. There's no body to this. So if we're to do some code to that, what we see there is it's basically a declaration of the public interface test, and then there's a public get test. There's probably a returning data type also missing there. But what we're seeing is that there's no method declaration. There's no implementation of that operation. So when we're working with interfaces, it'll just state the public interfaces. So from another classes, we will then work through the interface to get to the actual other classes. So let's say you wanted to go from class A to B. It might mean that you needed to go through the interface now. So you will go D, and the interface will actually just tell us which public operation we are then implementing.
Is that a controller?
It's not a controller. It's not a control class. It's an interface to a class or even a package of classes. So what it does, it hides away the actual implementation of this class. Okay, because you can't then directly implement that one sometimes. We see it a lot of times in APIs. Because in an API, what do you get? You get a package which tells us this is the classes, or this is what you can do. But the only way in which you can do it is to create an object of the public interface. And then from the public interface, it knows what and how to do it. Okay. So there's also examples of metamorphism where we're seeing that we have possibly a student which goes and becomes a full-time student. So that is just also things that we might need to consider when we're creating a generalization structure. Because what we're seeing in that previous one, we're still seeing name, address, student ID, name, address, student ID, maximum number of courses, and grade date. So in essence, it means to us that we can create a generalization structure where the common attributes is placed in the parent, and the unique ones is then placed in the appropriate unique children classes. So another approach to doing this is to possibly have the student and then to create a relationship between classification, and then from classification we can go and say, but this student can be a part-time one or a full-time student. So that's another way of modeling this. So there is an example where they're working with this in terms of the sequence diagram. What are we seeing change to full-time? Now what do we need to do is from the student, we need to remove them on the part-time classification, then we need to create a full-time classification entry for them. So there is a extension of this where what we're seeing is that it just extends it and makes it a bit more flexible if we want to extend the model later on. So what they've shown to us there, we have resident information. It doesn't really belong in the student because the student can actually reside in different rooms at different times. So they won't place this information inside the actual student, but model it separately. Okay, so then there's quickly just a mention about how to handle use case collisions. Now, what we see in this case is that multiple use cases may simultaneously access the, many different line objects at the same time. So we might need to look at a way of synchronizing these messaging. First come, first serve in some ways. Then, or we need to identify an operation or some specific code to protect that structure. Okay, so it means that, for example, if you go to a cinema and you are at these desks where you're booking a seat, can you book a seat and another person is booking the same seat? Okay, so what it's talking about is that we might need to look at a way of handling something like this, where you have multiple use cases or multiple sections in your program or your flow, which would like to actually access specific design objects. So it's almost like at the end of the month, if you go to a banking system, they would like to do a lot of withdrawals and interactions on your system. So that is things which you might need to consider. Okay. Guys, so for the rest of this, you can quickly go through it. You'll see, then it just talks about handling non-functional requirements. Okay. And then there's just a mention to add also. Okay, this is the last unit, and then we are finished. Okay. Any questions? Quite a lot.